Good evening, good morning, I don't know, good night. I don't know when you're watching, but thanks for watching. We're going to be talking today about section 11.3, balancing equations. And of course, all of the information in this presentation comes from your CK12 packet. So, first off, our introduction is going to have a discussion about leftovers. And we all always end up with leftovers, especially during the holidays, especially Thanksgiving, right? There's always we eat turkey for not just Thanksgiving, but for the rest of the week, right? So let's talk about that in today's introduction. Who's going to help me? When you cook in like often there are leftovers because you preparate more than people would eat at one sitting. Sometimes when you repair a piece of equipment, you end up with what are called pocket parts, small pieces you put in your pocket because you're not sure where they belong. Chemistry tries to avoid leftovers and pocket parts. In normal chemical processes, we cannot create or destroy matter. The law of conservation of mass, when we start out with 10 carbon atoms, we need to end up with 10 carbon atoms. John Dalton, atomic theory, said that chemical reactions basically involve the rearrangement of atoms. Chemical equation needs to follow these principles in order to be correct. Thank you, Yalexia. I know, Irvin, you tried to help me with the introduction, but Yalexia beat you to it. Sorry. She's already ahead of you. Yeah. All right. So either way, there's going to be a lot more to participate in. So don't worry. Um, First off, if you've ever taken apart a large engine or, even putting things together, I don't know if you guys have ever built like a crib or even like a shelf from, its parts. Sometimes you have some extra screws left over because you're not really sure, well, did they give me extra in case I lose one or something? Or, you're building an engine and all of a sudden you have these little extra parts and you're not sure where they go. It happens. It happens. In chemistry, we try to avoid leftovers, okay? We don't like leftovers. In chemistry, we like everything balanced out. First off, why? Well, because of the law of conservation of mass. The law of conservation of mass states that we cannot create or destroy matter. It can only be rearranged. So, if you start with 3 moles, you need to end with 3 moles. Or, I'm sorry, atoms, right? 3 atoms of hydrogen, you need to have 3 atoms of hydrogen at the end. If you have 1 carbon, you need to end with 1 carbon. Atoms don't disappear into thin air. They must be accounted for. Um, John Dalton also said in his atomic theory, and we talked about his atomic theory way, way back in the first 6 weeks. He said that all chemical reactions are basically rearrangement of atoms. Okay? They don't disappear into thin air and they don't get created out of thin air. They have to come from somewhere. So today, balancing, we are going to prove his theory about the rearrangements of atoms. We're going to prove the law of conservation of mass. Whatever you start with has to always be there, what you end with, right? So let's get the party started. First off, balancing equations. Balancing equations can be very complicated and confusing. But of course, you have the best teacher in La Jolla High School when it comes to chemistry. So don't worry, I'm going to be there to guide you and make sure that you do things correctly. Okay? I'm always there for you guys, so don't worry. A balanced equation, first off, is a chemical equation in which the mass is conserved and there are equal number of atoms of each element on both sides of the equation, right? The reactant side and the product side. That's what they're talking about. And remember, on both sides, they're talking about the yield sign, right? The yield sign is there to divide our products from our reactants. So on both sides of the yield sign, you should have equal number of each atom. We can write a chemical equation for the reaction of carbon with hydrogen gas to form methane.
So they're already talking of examples. They're talking about an example, a synthesis reaction, where carbon and hydrogen gas are coming together and creating methane, excuse me. In order to write a correct equation, you must first write the correct skeleton equation, right? You can't balance until you have all your ducks in a row. And all the ducks in a row means, do you have all the correct formulas? Okay? Once you have your correct formulas, then you can count, okay, how many atoms of each do I have? How many carbons on the left? How many carbons on the right? How many hydrogens on the left? How many hydrogens on the right? And then you need to make sure that they balance, okay? And I'm going to show you how to do that. Recall that hydrogen is known as a diatomic molecule, and so is written as H2. So anytime you run into these molecules, and there's a list of diatomic elements at the bottom of your ion sheet. So if you ever read hydrogen gas, you're going to write H2, nitrogen gas N2, oxygen gas O2, and so on and so on and so on. When we count the number of atoms of both elements shown under the equation, we can see that the equation is not balanced. So now they're looking at the numbers. They're looking, okay, on the left, I have 1 carbon. On the right, I have 1 carbon. On the left, I have 2 hydrogens. On the right, I have 4 hydrogens. Uh-oh, red flag. I got an unbalanced number of atoms for hydrogen. We don't care about carbon. Carbon's balanced. I got 1 and 1. The only element that I'm going to worry about right now is hydrogen. How I have 4 on the right, I have 2 on the left. I need to make sure that the 2 makes or is changed into a 4. And I'm going to show you how to do that, okay? And I'm going to go into Jamboard. So those of you who are on Pear Deck, come back to the Google Meet so that you can see Jamboard and you can help me with this. All right, this is the formula that we just talked about, or the reaction, right? So right now, I need to make a list. And I'm going to make a list right here on the border, right? My yield sign is my border between my reactants and my products. Okay, so I'm going to start by creating a list of my elements, which in the first element you can see is carbon. Your second element is hydrogen. All right, so let's do that. So I put carbon. I put hydrogen. Now, look at the formula for carbon. How many carbons do you see here? If there's no subscript, what number is present that you don't see? What number is present? Always a 1, right? So we're going to put a 1 here. And you can easily see, right, Miss Diamond? Look at Diamond's already is already figuring out the numbers. How many hydrogens do I have now? Well, I got 2, right? You can see the subscript here. So I put 2. Okay, now let's look at the other side. How many carbons for this guy right here? If there's no subscript, there's always just 1. Okay, what about hydrogen? What's my subscript? 4. So that's what I'm going to put here. Okay, now you can easily see that my carbon's balanced, right? I got 1 and 1. I'm not going to mess with that. If something is already balanced, you skip and you move on to something that is not balanced. Or in this case, hydrogen, right? Look at hydrogen. I got 2 here, I got 4 here. That's not balanced. I don't have the same number. So what am I going to do? I'm going to multiply by a number that's going to give me a 4. What can I multiply that equals to 4? What do I multiply in order to get a 4? What do I multiply by? What's going to go in this blank right here? A 2, okay? So I'm going to put a 2. Now, They balance. I got a 4 and I got a 4. But my question, okay, what number did I multiply by? What number did I multiply by? I multiplied by 2, so that number needs to go here so that we can have the correct number of atoms. Okay? You can never change your formula. You cannot change the subscripts. You cannot change the formula. The only thing you can do is you can put a number in the front that multiplies your compound so that you can get this number. Okay, so you're able to balance correctly. Okay, we call these numbers coefficients. You can only add a coefficient that will multiply your compound so that you can correctly balance your atoms. Okay, and that's what they showed you here on Pear Deck. It says here, there are only 2 atoms of hydrogen on the reactant side of the equation, while there are 4 atoms of hydrogen on the product side. We can balance the above equation by adding a coefficient of 2 in front of the formula for hydrogen. So look, they did it right here. Everybody sees the 2?
Yes, ma'am.
Yes, that's the same 2 that we had right here. Okay? All right. Now it's your turn. On Pear Deck, if you can, if you need help, of course, I'm going to be there. But if you can, I want you to make a list of your elements, and I want you to count how many do you have on the reactant side. I want you to count how many you have on the product side. Okay? If you're still unsure, I'm going to do it on Jamboard, but with your help. I'm not going to do it all by myself. You're going to help me count the atoms for each element. All right? Because I got it right here. Here's our formula. Okay. What's the list of elements? What's the first atom you see? What's the first element here? What element is this? Carbon, right? What's your second element? Hydrogen. What's your third element? Chlorine. Make that list, guys. Make the list. Check it twice. Make sure he's naughty or nice. All right, so here's our list. We got carbon, hydrogen, and chlorine. Now, let's count. How many carbons do you see here?
1.
Very good. So I'm going to put a 1. Good. Okay, next. How many do I see here?
4.
Very good. So we're going to put 4. And here?
2.
2 chlorines. Very good. Okay. Now let's go to the other side. The product side. How many carbons?
1.
Very good, sir. How many hydrogens?
1.
Very good, sir. How many chlorines right here?
And 4.
4. But isn't there another one, Urban?
Yeah.
How many?
Okay.
Plus 1 more. If you have an element that shows up in more than one formula on the product or on the reactant side, if there's a plus in between, you must include it. Okay? You see how the plus is here? That plus is this same plus here. So keep the numbers separated. It's going to make it easier for you to understand how to balance. Okay? And that's it for now. We're done for now. We're not going to balance yet. Balancing comes in the next Pear Deck question. Okay. Oh, did anybody do the numbers? Oh, look at that. Somebody was actually trying to do it. Great job, whoever that is. Whoever started to try and do it, at least you tried. Thank you. Okay, now let's talk about what a coefficient is. The number that we put in front of the formula to balance, right? A coefficient is a small whole number placed in front of a formula in an equation in order to balance it. The 2 in front of the H2 means that there are a total of 2 times 2 equals 4 atoms of hydrogens as reactants. Who left? I don't know who. Somebody came in and left. I didn't see it. Visually, the reaction looks like the figure below. So now we're comparing this formula. Oops, not this formula. This formula or this equation with the equation right here. We had 1 atom of carbon. There's your 1 atom. There was 2 atoms or 2 moles of hydrogen gas. Here's hydrogen gas, and there's 2 of them for a total of 4, right? 4 atoms. And you can see and you can count, okay, I got 1 carbon, 1 carbon. 4 hydrogens, 1, 2, 3, 4. Okay? This is a reaction between carbon and hydrogen to form methane. Any questions on the first example question? Anybody have a question? In the balanced equation, there is 1 atom of carbon, 4 atoms of hydrogen on both sides of the arrow. Below are guidelines for writing and balancing chemical equations. All right, let's check out these guidelines. Number 1, determine the correct chemical formula for each reactant and product. Number 2, write the skeleton equation. Number 3, count the number of atoms of each element that appears as a reactant and as a product. If a polyatomic ion is unchanged on both sides of the equation, count it as a unit, okay? So if you see NH4 on the reactant side and NH4 on the product side, you're going to keep NH4 together on your list, okay? And don't worry, I'm going to show you an example of what I mean by that, okay? So if you're not really sure about what I'm talking about in that last part, there is an example coming that will involve ions or polyatomics. Balance each element one at a time by placing coefficients in front of the formulas. It is best to begin balancing elements that only appear in one formula on each side of the equation. No coefficient is written for a 1. If there's no number, if you don't put in a coefficient that's a 2 or bigger, then leave it blank, okay? 1s are understood. You do not need to be showing 1s for the coefficients, okay? Hey, Jeremiah.
Sorry, David.
It's okay. I know your internet's wonky. Okay. Never change the subscripts in a chemical formula. You can only balance equations using coefficient. So why don't we want to change the formula or the subscripts? Because that's going to change the compound. If you change the compound, you're changing the reaction, and then everything gets thrown off. Never change formulas, guys. Never, never, never. Only coefficients. Check each atom or polyatomic to make sure they are equal on both sides of the equation. Make sure that all coefficients are in the lowest possible ratio. If necessary, reduce the lowest ratio. If you do this correctly, you don't have to worry about number 6. If you balance correctly, your numbers are already the lowest possible numbers, okay? So what's next? Sample problem number 1. There's really only one. Balancing chemical equations. So here's our sample problem. Aqueous solutions of lead 2 nitrate and sodium chloride are mixed. The products of the reaction are an aqueous solution of sodium nitrate and a solid precipitate of lead 2 chloride. And here's, they tell you, step 1 is always plan your problem. What do you know? What don't you know? Follow the steps for writing and balancing a chemical equation. Step 2, solve. Write the skeleton equation with the correct formula. And then count the number of each atom or polyatomic ion on both sides of the equation. Now, yesterday we did not practice writing chemical equations, We talked about it, but we did not practice it. So guess what we're doing today? We're going to not only balance, but we're going to practice writing chemical equations. So let's go into Jamboard. So look, I didn't cheat. There's no skeleton equation for me. We are going to write it. First off, I need the valence sheet, right? I need the ion sheet to know the symbol and the charge for my ions. And it starts by saying lead nitrate. So I need to look up lead and I need to look up nitrate on the sheet. Lead is down here towards the bottom. Pb, and it's either a +2 or a +4. Okay? Look at this. Everybody see the Roman number? That Roman number tells me that Pb is a +2. Nitrate, we can look it up on the sheet. It's right up here on the right side. NO3 with a -1 charge. NO3 with a -1 charge. So that's what I write for nitrate. NO3 with a -1 charge. Sodium and chloride. Excuse me. Sodium, Na+1. Chloride is just chlorine with a -1 charge. So Na for sodium, it's got a +1 charge. Chlorine has a -1 charge. And now my products should just rearrange these compound or these ions. So I don't need to go back to the valence sheet. Everything I need is here. Why? Because look, you have sodium. We have sodium right here. Na with a +1 charge. Nitrate. It's right here. NO3 with a -1 charge. Lead-2, don't we know lead-2? We know it's Pb with a +2, and chlorine or chloride is a -1 with a Cl, or Cl -1, sorry. Now that we have the ion and the symbol and the charge for each element that's present, we can write formulas, right? Okay. So this guy does not cancel out with the -1, so it needs to cross down. And that's going to give me a formula of PbNO3, and that's going to be in parentheses with the 2 on the outside. And since it says it's aqueous, I can also include the physical state of it. Okay, then we have sodium chloride. A +1 and a -1 cancel out because it's the same number. This guy cancels with this guy. So I end up with NaCl. And it also says that it's aqueous. So I'm just going to put AQ in parentheses on bottom. And it's going to yield sodium nitrate. +1, -1. If it's always the same number, it cancels out. And you just write the elements, or in this case, oh, no, I don't need parentheses. What am I doing? NaNO3. And it's also aqueous, so let's put in there the physical state. And then Pb, well, I got a 2 and a 1, so that's not going to cancel. So it always crosses down. So you end up with PbCl2. And of course, it says it's a solid lead-2 chloride. So that's your formula. And you can verify that because you know what? I cheated and I put the skeleton equation here. PbNO3 in parentheses with a 2 on the outside. That's what they wrote. NaCl. NaNO3. NaNO3. And then PbCl2. Very good. Now that you have the skeleton equation, now you can make a list of your elements and count how many atoms of each you have. Okay? What's my first compound or my first element? Pb. So that goes here. My next one, look at this is what we call a poly, right? Do you notice that this poly shows up on both sides of the yield sign? If a polyatomic, and remember, the polyatomics are all right here. If any of these shows up on both sides of the arrow, you're going to keep it together. Does NO3 show up on both sides? Yes. Will we keep it together? Yes. Very good, Irvin. Okay, what comes after that? Na and Cl. Okay, everybody good on that one? All right, let's do this. I just wanted to make sure you can see the N. It looked a little confusing. Okay, now let's count. How many leads? How many leads do you see here? If there's no number, what's my number?
1.
Very good. So we put a 1. How many nitrates? Remember, NO3 is a 1, right? All of NO3 is already counted. The 3's already in here. So what number is outside? How many do we have?
2.
2. Very good. Okay. What's next? Sodium. How many sodiums? How many chlorine?
1.
How many chlorines also? Oops, 1. Right? 1 and 1. Very good. What about PB over here?
1.
Okay. How many NO3s? What numbers on the outside that you don't see?
The 3.
The 3's already counted. What numbers outside that you do not see? What number is always invisible? A 1. Okay. Why did I not put 3? Because the 3's already counted. It's part of the poly. So always think about it. Okay, if there's parentheses around this guy, what number's outside that I don't see? A 1. Does that make sense? Okay. Na. How many NAs here? And then chlorine. Okay. Now that I have my numbers, what should I start with? Should I start with lead? Should I start with lead?
No, that's not really.
It's balanced. So we're going to start with nitrate. Look at that. I got a 2 and I got a 1. What am I going to multiply by in order to make this into a 2? I know very good. I need to make a 2. What am I going to do? I'm going to multiply by 2. Okay. Let me erase this. Okay. So where is that element? Where is nitrate? Is it here or is it here? The first one or the second one?
The first one.
So that's where I'm going to put my 2. And remember, it's not because of the 2 that equals, it's because of the 2 that I multiplied by. Okay? So, but who else is connected to nitrate that got affected? Who else got multiplied by 2 other than the NO3? Who else is attached to NO3? Who else is attached? Na. Very good, Miss Diamond. So he also got multiplied by 2, didn't he? Yes. He also got multiplied by 2, so I get a 2 here. Well, doesn't that throw off my numbers? This cancels with this, right? Because they're the same. This over here is the same. But now I have a 1, but over here I have a 2. What's my only option? What do I multiply so I can make this into a 2? What goes here?
So,
Yes, sir. I'm going to put a 2 in here so that my sodium gets multiplied on the left by 2. That's going to make me also put a 2 here, but somebody else also got affected. What happened here when I put that 2 in there? Who else also got multiplied by 2?
okay.
The chlorine also got multiplied by 2. But isn't that what we need? Do I need that to happen?
Yes, ma'am.
I do. Why? Because this 2 needs to cancel out with this 2, or match, not cancel out. It needs to balance with it, right? So now my 2's are balanced, my chlorines are balanced, and we're done. And you can look on Pear Deck and see the same answer. They put a 2 in front of NaCl. They put a 2 in front of NaNO3. And look, they end up with the same numbers that we have. 1, 2, 2, 2. 1, 2, 2, 2. Isn't that what we have? 1, 2, 2, 2. 1, 2, 2, 2. We're good to go. Okay? Now it's your turn to try it. Now it's your turn. I want you to help me balance this guy. You tell me what to do. What do you want me to do to balance this guy right here? I don't want to mess with carbon. Carbon's balanced. Where do I start?
1 times 4.
1 times 4. Very good. Irvin is saying 1 times 4, miss, so that hydrogens can balance. Where's hydrogen though, Irvin? First compound or second compound? Second compound. Okay, so I'm going to put the 4 in there. Who else got affected? Who else got multiplied by 4? The one with the 4 or the one with the 1?
The 1 with the 1.
The 1. It's no longer a 1. It's 1 times 4. So this guy changes to a 4. Okay, let's do it. Okay, he is now a 4. Uh-oh, that makes an 8. I only have 2 on the left.
Oh, you got to multiply by 4.
Very good, sir. He says if we multiply this guy by 4, Miss Hernandez, I'm going to make 8 chlorines. And we're done. Any questions? Any questions on that one? Balancing takes practice. Practice, practice, practice. Okay? If you are confused here, don't worry. I'm always available for extra tutoring if you want to come and maybe do some extra practice with me after school. I can't do it here in class because we're running out of time and we got some questions we need to answer. Come see me after school on Google Meet. Monday, Tuesday, and Wednesdays from 4:30 to 5. Okay? Monday, Tuesday, and Wednesday. All right. Let's close out the presentation. If we have time, we'll watch some of the video. The process, in summary, the process of balancing chemical equations is described. Your review questions. What is the law of conservation of mass? How did Dalton describe the process of chemical reactions? why don't we change the subscripts in order to balance an equation? All right.